Hello, my name is Joseph DeVogais. I work for KDE. I'm the Community and Project Manager for Blauer Engel for FOSS, which is one of the projects in the KDE Eco initiative. My talk today will be about the achievements, impact, and aspirations of the KDE Eco project. If you have questions, please type your questions in the chat box during my presentation. I will do my best to answer them quickly.
Information and communication technology produces 3% of all global carbon emissions. Unless we do something, in 2050 it will reach 30%. What can we do? Software may be immaterial, but it still runs on hardware and determines its energy consumption. Making software energy efficient is crucial. Say hello to KDE Eco. We promote energy efficiency in the Blauer Engel Eco certification for free software with 3 simple steps: measure, analyze, and certify. Make energy efficient software a reality. Visit eco.kde.org and join us.
That was a short promotional video we made for the project at the beginning of this year. I will return to some of the topics, like the 3 steps to Eco certification, at the end of this presentation. But for now, I want to focus on some of the numbers at the beginning of the video. The Association for Computing Machinery released a policy report in 2021 in which they estimate that the ICT sector contributes between 1.8 and 3.9% of global carbon emissions. To put that into perspective, the aviation industry contributes about 2.5%. So the ICT sector is more or less in the same ballpark. The numbers for the estimates here include everything from Bitcoin, machine learning, and other forms of artificial intelligence to the production and transportation of digital devices and their use. The report starts by stating that computing can help mitigate climate change, but it must first cease contributing to it. And that's particularly important when you consider that if nothing changes, it's expected that the ICT sector will contribute about 1/3 of all global carbon emissions by 2050. To get an idea of what the distribution of the energy consumption in the ICT sector looks like, this is a plot from the SHIFT project. In this plot, it's not included information about transportation of the devices or end-of-life treatment, as well as things like Bitcoin. On the top right, you see the production of TVs, computers, and other types of digital devices. And on the bottom left, you see the usage in data centers, networks, as well as terminals. Terminals here meaning our laptops, smartphones, tablets, etc. And what you can see here is that the production of digital devices is about 45% of the total energy consumption, and the usage is 55%. Now, my talk today is not going to focus much on the production. I will make a couple of comments. If you're interested in this, I have talked about this in some other talks in the past. I also will have nothing to say about data center and network usage. I'm going to focus primarily here on desktop software. This is an area where KDE, as well as perhaps Qt and other software developers, can have a direct influence on the energy consumption of digital technology. When I'm talking about energy efficiency, here's a plot from the German Environment Agency released in 2018, in which they compare various software products doing the same thing. Okay, so here I'm going to focus on the far left bar plots, which is 2 word processors, word processor 1 and word processor 2, doing the exact same thing in what is referred to as a standard usage scenario. Now, you can see in this bar plot that word processor 1 consumes about 4 times the energy than word processor 2. Now, for an individual user, this difference may not mean much, but when you think about it at scale, every university, every office, every home has a computer running a word processor in it. And when you multiply a single user by billions of users, suddenly those numbers really add up. Now, as developers, once we have information about the energy consumption of our software products, we can make data-driven decisions about development. We can think of ways that we can drive down the energy consumption of our software so that we are consuming less. As users, once this information is transparent, we can make informed decisions about which software products meet our needs and have the least environmental impact. In terms of energy conservation, again, this is comparing two different word processors from that same report from the German Environment Agency. The top plot here is from the first word processor, and the bottom plot is from the second word processor. Now, I'm going to focus on everything that happens after the blue line, more or less in the middle of the plot. I'm not going to talk about anything that happens before that. The x-axis here is time while running the standard usage scenario, and the y-axis is the power consumption. What you can see here at that blue line, that's the moment when the usage scenario saves the document and goes idle. When you look at the bottom plot for word processor 2, you can see that in fact the software product goes into an idle state and remains so. By comparison, the upper plot from word processor 1 continues working. What is happening, we don't know. If it's free and open source software, we can take a look to see what's happening behind the hood and perhaps consider if those processes are necessary for the use of that software. We can also think about how to allow users to have choice about these extra processes that may not be necessary for the use of that software, so that they can reduce the energy consumption of their software on their own. The first achievement I want to talk about is the Energy Consumption Lab that was set up at KDAB in Berlin. The Energy Consumption Lab is a place for free and open source software projects to measure their software products when running standard usage scenarios, with the goal of providing input for data-driven decisions about software engineering, as well as to certify software products with the Blue Angel Eco-label. Here is a screenshot from a blog post where you can read more about the 3 sprints we held this summer to set up the lab. What does the lab setup look like? Well, there's a system under test. This is a dedicated machine to run the software that you want to test. It has to be set up in a certain way so that processes are not running unnecessarily, for example, automatic updates and other things that can contribute to energy consumption that are not relevant for the software you want to measure. The system under test is connected to a power meter, which is an external power meter measuring the power draw when the system under test is used. The data from the system under test in terms of hardware performance, like CPU usage, network traffic, etc., is collected. The power meter data is collected, and both of those are then aggregated and evaluated on a separate computer. Power meters are not cheap. A KDE contributor, Volker Krause, has hacked a cheap power plug. It cost about 10 euros to give a inexpensive power meter option for those who are just interested in getting an idea of what their energy consumption looks like when using their software product. You can read more about it at the blog linked to in this presentation. What do you measure when you use the lab? There are 3 scenarios to measure if you want to eco-certify. The baseline, which is just the operating system when running. The idle mode, which is when the operating system is running and you open the application you are interested in testing. As well as the standard usage scenario, which is a script representing the most typical functions of that software product and how most users would use it. Which brings us to achievement 2. When running your standard usage scenario script, you want to run it multiple times so that you can do robust statistical analyses and separate the signal from the noise. To run these scripts, it's necessary to have a tool to do so. There are tools that existed prior to the KDE Eco project. For example, Acciona was one used by the Umweltcampus, which is a point-and-click scripting tool to emulate user behavior. This tool was, although it's easy to use, is not very robust. It's a pixel-based tool, which means if you change monitors and screen resolutions, suddenly the clicks will not be in the correct place. To to find a better way to do this, a KDE contributor, Nico Fella, who wrote his master's thesis on energy consumption using different emulation tools, used a xdo tool script, which is a command line based script and allows for more robust transfer of the script to other computers. Now, this tool was then further developed by G-Compre contributor from KDE, Emmanuel Charu, who developed a tool called KDE Eco Tester, which combines some of the benefits of the point-and-click method, but scripts it using xdo tool in Python. Achievement number 3, collaborations. So the work we're doing here, we could not do alone. In fact, it's work that is being done with multiple other people who are all working towards the same goal, which is a sustainable digital society. The Umweltcampus Birkenfeld is a research institute working on sustainable software, and their methods are the basis for the Blue Angel, as well as for what we're doing in our lab and with our emulation scripts. Green Coding Berlin is a project which is providing a container-based tool for measuring energy consumption of software using various metrics, not just external power meters like what we have set up in our KDAB lab, but also internal measures using various sensors, and among other things. The Sustainable Digital Infrastructure Alliance is a large project looking to push sustainability in the digital infrastructure in general, from data centers to the network to terminals. And the Green Web Foundation is a project which is seeking to make the web carbon neutral by 2030. With the Green Web Foundation, KDE Eco is currently seeking funding to develop a tool to make updating more renewable energy friendly, which I will return to later. The Green Coding Berlin project has contributed numerous things to the KDE Eco project, including setting up the lab with us in KDAB. And the Sustainable Digital Infrastructure Alliance has provided much input and opportunities to present our project and to learn from theirs at various workshops. Finally, Achievement 4 is the Eco Certification of Okular. This is the first ever Eco-certified computer program in the Global Eco-Labeling Network, which is a 30-plus network of eco-labels around the globe, representing about 60 countries. And KDE is proud to be the first to certify their popular PDF reader, Okular. The eco-certification requires fulfilling what I'm calling the ABCs of the Blue Angel Award criteria. A, resource and energy efficiency, that is providing transparency in terms of the energy consumption and hardware performance when running the software idly and when running the standard usage scenario script. This way, users can be informed about how much energy the software they're using consumes. B, potential hardware operating life. Does the software run on hardware that's at least 5 years old? This is to prevent software-driven hardware obsolescence. 5 years is not very much. That's from today in 2017. Many of KDE software products can run on hardware that's much older than that. And finally, user autonomy. And this is where free and open source software really shines. Many things that we take for granted, such as uninstallability, modularity, transparency, and support for open standards, etc., are recognized as being more sustainable and giving users more control over the energy consumption of the software they use. Let's move now to the impact of the KDE Eco initiative. Impact number 1 is pushing a conversation in the general public. As part of this push, we have reached out to various publications and have had articles and posts made to various websites, including the Taz, a German-wide newspaper. Hacker News had a post about us, which was trending after the eco-certification of Okular. The usual suspects of Netzpolitik, Linux Magazine, OpenSource.com all had articles or interviews. FSFE also published various reports. What's nice to see is that also publications like Transform are interested in the KDE Eco project. Transform is a print publication which covers various topics, not necessarily digital ones, and they did an interview for their most recent release. Impact number 2, FOSS community outreach. As part of the project, we've done presentations at various conferences and workshops. For example, Qt DevCon in June, now Qt World Summit today, Linux App Summit, Chaos Communication Congress 2021, Grazer Linux Tage, SFSCon, both last year and this year, Fedora Nest, and Green Coding Berlin. We've also done some community outreach to spread information related to Blue Angel Eco-certification and push a conversation about energy consumption in free software. And this has included Qt, GNOME, Fedora, the Document Foundation, KDAB Berlin, Mozilla Firefox, among others. Impact number 3, perhaps one of the more important ones, KDE Code Improvements. Since November last year, we have started labeling merge requests and bug reports with a tag efficiency. Now these merge requests and bug reports are related to things like unnecessarily high CPU usage, software that hangs, when things crash unnecessarily, etc. Since introducing this tag, we've had 130 plus efficiency merge requests since then. Now these slides were made about a month ago, so we've had more even since then. And the benefit here is we can then track what are we doing to make our software more efficient. Finally, social media, impact number 4. Now, the information I'm going to present here is not, I'm going to present different social media platforms, Reddit, Twitter, Facebook, and Mastodon, and not all of the information is directly comparable since we receive different information from different sources. Let's start with Reddit. Here is just a graph of the number of posts on Reddit since November 2021 to September 2022. You can see that non-eco related posts, labeled here as other, far outnumber the eco-related posts. So the non-eco ones are about 122, eco ones are about 15. Now, these posts, let's look at them in terms of their engagement. Again, the red here is the eco posts and the blue is the non-eco posts. And what we have on the x-axis are the number of likes, and on the other way around, x-axis number of comments, and on the y-axis the number of likes. And what you can see here is that the Reddit posts, the eco posts, have received a lot of likes. The top 2 most liked posts on Reddit from the past almost year have been the eco-related ones, in particular the Okular and Blaue Engel certification. And the third most liked post here is the launch of our eco.kde.org website. Now, the other posts also had a lot of comments and engagement, in particular the KDN fundraiser one. But I want to show that in Reddit, it seems that the eco topic is quite interesting to Reddit users. I was interested in not looking at just the subreddits that are the usual suspects for free and open source software, like rKDE, rFOSS, rFree software, but the non-FOSS related subreddits, both for the eco and non-eco posts, to get an idea of what the engagement looks like there. And what I find interesting here is you can see the eco posts have a lot of likes. In fact, for the non-FOSS related subreddits, all of the eco posts were the most liked in comparison. You don't see much engagement in terms of comments, which may be not surprising given that software sustainability is probably something that many people haven't really thought about much. So it maybe isn't surprising that people aren't as engaged in the comment section. Now let's move to Twitter. So this data is from January until August. Here again, non-Eco related posts are in blue and Eco ones are in red. What you see here is a slightly different picture. The Eco related posts are less engaging than the non-Eco posts, and the number of impressions is also lower, meaning less people saw it. What's interesting here is this the distribution of what is engaging. For the top 3 posts, again, Okular and Blaue Engel is the number 1 post, but the second one is the video we saw at the very beginning of this presentation, the Say Hello to KDE Eco, which is the number 2 in terms of engagement, likes and comments. And the G-Compris data efficiency improvements made, which we wrote a blog post about, also was quite popular on Twitter. Whereas for the non-KDE Eco posts, it's the usual KDE Plasma as well as other topics related to that. Now moving on to Facebook, this is for Q1 and Q2. Q1 here, you can see there's not many Eco posts compared to non-Eco posts, and you see that the engagement is much lower in general. The same thing for Q2, again, not so many posts, and then engagement again is much lower. So it seems so far we can say that between Reddit, Twitter, and Facebook, Reddit users seem to be the most engaged with the Eco topic, whereas Twitter is a bit less and Facebook the lowest. Now, I don't have a reliable analytics tool yet for Mastodon. I would be interested in this and something that came out of preparing this presentation to have some analytics about the publicly available information. For now, this is just looking at the Eco posts. There's been almost 20 of them from November until October, and just getting an idea of what the engagement looks like, in particular which posts are the ones that are most interesting. We can see here that for the Mastodon users, again, Okular and Blaue Engel is one of the more engaging posts. The Right to Repair, which is a FSFE initiative, which basically states that the right to repair hardware must also include software. This was also very popular in Mastodon in terms of the number of favorites and boosts. And then the Say Hello to KDE Eco post. Now we'll move on to the aspirations of the KDE Eco project. The first one is a measurement handbook. The goal is to provide a guideline for other software developers who want to set up a measurement lab and eco-certify their software. The first edition will be released in the end of this year or the beginning of next year, and it will include 3 main sections. Section 1 will be an introduction to software-driven energy consumption, similar to the beginning of this presentation. The second section will be the Blue Angel Eco Label for resource-efficient software development with a case study in Okular. And the third section will be a hands-on guide to measuring the energy consumption of software so that users can follow a point-by-point guide to then measuring their software, getting the report, and making a application for the Blue Angel Eco Label. Aspiration number 2, measuring and certifying more FOSS software. One of the goals is to encourage people to set up labs with using the handbook, to prepare standard usage scenarios for the software they develop. There's information about this at our eco.kde.org blog. If you're going to use the measurement data for Blue Angel Eco certification, you must also measure the baseline and idle mode. And if you're interested in this, please be in touch. We would love to have more people get involved in measuring their software, applying for the Eco label, the Blue Angel Eco label, among other things. To note, this is data from Qt text editor. This is just preliminary data when running a standard usage scenario prepared by our Season of KDE student Karanjot Singh. This is just preliminary data for presentational purposes. Our third aspiration, to develop measurement tools. So I already talked earlier about the emulation scripting using XDo tool and the KDE Eco tester. In the future, we would like to further develop tools so that the lab that we've set up in KDAB Berlin is accessible remotely. For this, we will need some sort of online portal where developers can upload their software as well as the usage scenario script, and then have the software run on the lab hardware and provide a report automatically. Now, part of this will also be automating the measurement process as much as possible. The emulation tools that we currently have are X11 based, and we would like to work on more robust emulation tools which also work on Wayland. For example, there's a discussion right now of using Selenium for usability testing, and perhaps implementing that for energy consumption measurements would make it a more robust tool, which will also then allow us to measure software using Wayland. I mentioned this briefly earlier. We have the idea of a carbon-aware updates. Here is a graph, which is an abstraction of the power grid in terms of the renewable power supply on the y-axis and the time of day on the x-axis. And what you can see here is that at certain times of day, there's more power supplied by renewable sources than at other times of day. And one of the ideas is to take the data, which is to some extent available, and incorporating that into updating tools like KDE's Discover, among others, so that shiftable tasks like updates can be done at times of day when the renewable sources is highest. Finally, our fifth aspiration, extending the outreach. We have the idea of extending the outreach to users beyond, so far the project has been focused on developers, but to focus more on users as well as multipliers, power users, environmental activists, young people who might be aware of the issues related to digital technology and the environment, and develop awareness-raising tools so that users can become more informed about how their use influences the energy consumption of software. We also have the idea of upcycling hardware workshops where hardware that's no longer supported by the companies can be continued to stay in use by installing GNU Linux on it and reducing the energy consumption, the very high energy consumption for the production and transportation of those devices when they're new. Also want to develop best practice guidelines, both for developers as well as for users, as well as an EcoPlasma widget, which would be a tool to give some information about energy consumption real time, which software products are consuming the most energy over time, as well as perhaps clickable links to information about things like eco-certification or other transparency reports related to the energy consumption of that software. To conclude this presentation, I just want to provide some information about how you can get involved. If you would like to contact me, you can reach me at joseph@kde.org. You can also follow us on Mastodon. If you would like to join the larger community, you can join our monthly meetups in Big Blue Button the second Wednesday of the month at 7 p.m. Berlin time. In these meetups, we discuss various topics from different approaches to measuring the energy consumption of software to the tools that we're developing for emulating user behavior, etc. You can also join our energy efficiency mailing list or matrix room to discuss with community members various topics that you're interested in related to the energy consumption of software. We would love to have more people contribute to various aspects of the project. So if there's something that I talked about today that you find particularly interesting, please reach out to us. We would love to have you join us. Thank you.